Hi, me again. You missed me, I'm sure. So now we're on 7.2a, the lesson, the rational number system. Underline those first 5 letters, which are what? Ratio. And a ratio is a comparison of two numbers, and you guys are going to learn a little bit more about this later on. So you're supposed to sort all these numbers out into different categories, but I think it's going to be too difficult without a little bit of a hint from me first. So quickly write down these little terms to help you sort things out here. Natural numbers are numbers that we count with, like what comes naturally to human beings. So when a baby learns to count, they usually start with the number what? No, not 0. They usually start with 1. So think of the counting numbers as the natural numbers, because that's actually the name of another name for the natural numbers, counting numbers. So 1, 2, 3, etc. The whole numbers here are the exact same thing as these, except they add one little extra digit, and I'm just going to give you a little hint there. Now, these numbers and these numbers are missing something. How about stuff that's to the left? And I don't mean of my paper or your desk. I mean to the left of these numbers or these numbers. So integers are those. And then again, the first 5 letters of the word rational is ratio. And a ratio is something that is a comparison by division. So think of that. So go ahead and press pause now and try to sort these numbers. Write the numbers in the box that it corresponds to. When the video comes back on, you should have this filled out and talk about why you have it correct, incorrect, and fix any mistakes you have. Okay, the only natural number on the list is 45. It's the only counting number. The only whole number in addition to 45 is 0, so notice that they repeat here. You can have a natural number that is a whole number and so forth. So then we have the integers, and the only thing different about natural numbers, whole numbers, and integers is that the integers include these guys, the negative numbers. So then everything else in the whole chart here is actually a rational number, except for a few of them. And the few, the ones that don't fit into any category, are the ones circled down here. This guy, known as pi, this guy, this guy, this guy, this guy, this guy. The dot, dot, dot means continues here. This guy and this guy. So these 1, 2, 3, 4, 5, 6, 7, 8 don't fit into any category. So take a guess what they're called if they're not rational. If they're not rational. Okay, go ahead and now turn the page after you have checked all these. Push pause if you need to go over which ones are correct or not. Turn the page, and now let's define some stuff here. On page 41, whole numbers, natural numbers, integers, and rational numbers. Okay, so we're going to define them and we're going to graph them on the number line. So let's start with natural numbers. So natural numbers start at what number? Well, they start at 1 and go on like this, just counting numbers. Dot, dot, dot. Okay? That is the natural numbers. Starting at 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what's the difference between natural numbers and whole numbers? It's the number 0. So basically all of these numbers are here also, except we're going to, instead of start at 1, we're going to start at 0. So it's 1, 2, 3, and so on. Okay? Natural numbers are counting numbers. What's the difference between natural numbers and whole numbers? Whole numbers are the natural numbers. And one little additional guy there. And 0. So it's just one extra number for the whole numbers. Well, what are the integers? Aren't the integers everything to the left of this? I hope you've figured that out. The negatives. So the integers are 0, 1, 2, 3, and so forth, and negative 1, negative 2, negative 3, and so forth. So the integers are really all of these whole numbers, and of course natural, and their opposites. So the integers are the whole numbers and their opposites. So now you have a definition of natural, whole, and integers. Then there's one more thing that none of these number lines have on them. All these numbers are right there at nice, neat intervals. But of course, what's between here? What's between 1 and 2? What's between negative 1 and negative 2? What's right here? Well, of course, those are fractions or decimals, right? And that's what rational numbers are. Rational numbers are all of these numbers, and in addition to these numbers, all the numbers between those numbers. So basically, rational numbers are really fractions, decimals, and all integers. But that's really not the formal definition. It's not the definition of rational numbers. Rational numbers are, here's the definition here, any number that can be written as the ratio of two integers. So any number that can be written as a ratio of two integers. And what I mean by that is really, can you write it as a fraction? One integer on top of another. So the rational numbers are all the fractions in between here that you can write as a fraction. Okay? That's what the rational numbers are. Then that leaves one last question to answer is what else is left? Are there numbers between, for example, 0 and 1 that you can't write as a fraction? It's a question we need to discuss as well. So turn the page and let's go to the last couple concepts we're covering today. Change the following rational numbers. What do you actually see here? You should see, well, they're fractions. These guys are rational numbers. They're fractions. They're written as the ratio of two integers, something divided by something, without using a calculator. So how do you do that? Well, I just gave you a hint. Something divided by something. Well, what goes in the house? Is it 9 out here and 5 inside, or 9 inside? Which one's which? Well, this is read as 9 divided by 5. So that's the way this one's written. And then you're going to change it into a decimal. Well, how many 5s in 9 is 1? 1 times 5 is 5. Subtract, you get 4. So what do we write? R4, remainder 4? No. We need to make it a decimal, so you, of course, remember that you've got to do this and pretend like this is 40. 5 goes into 40 8 times, so 8 times 40 with no remainder is our decimal equivalent, 1.8. Let me just write that, 1.8. Isn't that really 1 and 8/10? Isn't that really 1 and 4/5? Isn't 1 and 4/5, excuse me, as the sorry, lights went off, now they're back on. 1 times 5 plus 4, isn't that 9/5? So done. Go ahead and do the same for all of these. Do the division, no calculator. Do it until the decimal ends. Push pause now and continue these, please. Okay, now you should have all these answers. So you should have this decimal, 375 thousandths is 3/8. 0.3, and of course you hopefully remember what this symbol means. It was going on forever, so 0.3 repeating, right? Letter D is 0.26, and the 6 repeats, but not the 2. Only the digit that repeats is the one that you put this repeating bar over. Now, if you weren't patient enough to actually take this all the way to the end, you needed to do this. It's all the way to 1, 4, 2, 8, 5, 7, and then it would start over again. So actually, all of these digits would repeat for 1/7. Let's answer these questions. Do you notice anything about the expansion, decimal expansion is what this is called, about any rational number? Well, every one of these fractions, the decimal Well, it either did what this decimal did, which is stop, like this one, or it does what this decimal does, which is repeat, right? The decimal either stops, and I'm going to use the correct word, which is terminates, or repeats. Okay. How do we convert a terminating decimal to a fraction? How do we convert a terminating decimal into a fraction? Well, that's actually what they're asking us how to do here. How do you do this going backwards? How do you take 1.8 and make it into a fraction? Well, I kind of gave you a hint right here. How would I read that correctly? 1 and 8/10. Oh, so you just read it and simplify. So for example, how do we read that properly? No, not 0.05, 5 what's? 5 over 100. And that can be simplified to 1 over 20. Okay, do the rest of these the same way. Say them to yourselves in the group out loud. How do you read it? Say it and simplify. So read it and simplify, or say it and simplify. Okay, press pause. Do those now, please. Okay, 11 over 40 for letter B. 1 and 3/1000ths. Now, before I go on, let's see if this is actually written as a ratio of two integers. Well, it's not. It's actually a mixed number. But of course, you know how to change a mixed number into an improper, which is simply just take that times that plus that. So really, it's 1 times 1,000 is 1,000 plus 3 over 1,000. So that is the ratio of two integers, and it's also a terminating decimal. And last but not least, -2 and 6/100ths, which is -2 and 3/50ths. And if you convert that into an improper, 2 times 50 plus 3 is 103 over 50, and don't lose the negative sign. Okay, one last pause here. All right, what I've realized is that I'm upside down. What I've realized is that the rest of this is going to be too long to fit on this 15-minute video. Now I'm talking to you and you don't actually see me, but I'm right here still. So you're going to have to go to your third and final video. If you need a 2-minute break, ask your substitute teacher nicely if that's okay. If not, suck it up and get to work. So the third video is yet to come, where we're going to do actually the only stuff that should be new to you.